Hi, this is Tempter Podcast, Innovation with Open Source. Today we have a special guest episode, and what happens with cutting edge hardware and software technology intersect. We got to talk to Alex Bradbury about RISC-V and LLVM. Alex is well-known open source community contributor, and he was recognized for his RISC-V LLVM by RISC-V International Board with a Software Contributor Award last year. He has co-founded not-for-profit open source Silicon organization Low Risk, so we'll talk about that. And going further back, was involved in early days authoring some books about learning Python on Raspberry Pi. So we'll uh, talk about that as well and get some tips on how to do long form writing. So hi, Alex. Hi, Cliff.
Hello.
So, Alex, tell us a little bit about yourself. Brief about your career and what do you do these days?
Sure. All right. I'll try and give the short form, and I imagine we'll loop back around to some things. So I'll get like many getting into tech. I studied computer science at university. I then kind of went on to study for a PhD, though that became a rather convoluted process that I got distracted with other things that came along. But it did get me diving right into the deep end of LLVM. So I was working on, I did a binutils port for a novel research many core architecture, did an LLVM backend for it. Got distracted along the way with Raspberry Pi. So my PhD supervisor at the time was a co-founder of Raspberry Pi. I got very involved kind of helping out on the software side in the early days. If you look way back, you'll see some references to me as the lead Linux developer or something along those lines, which basically amounted to doing an awful lot of packaging work, sorting out the kind of baseline Raspbian distribution images and so on. After I kind of moved on from that, I got distracted again with Low Risk. So I co-founded that with Rob Mullins, who's my supervisor, and Gavin Ferris, who'd approached us kind of having seen Raspberry Pi and was interested in doing something that could bring the benefits of open source to Silicon world. And so we went down the route of starting a not-for-profit that would try and make that a reality. I kind of grew that over 8 years working as CTO. Has had a huge success with OpenTitan with Google and is still going, doing great stuff. But about 3 years ago, I after sometime along then, I'd got involved. I'd managed to do a fair bit of engineering work through upstream RISC-V LLVM, but then less and less engineering work over time as Low Risk grew, and so I moved to Igalia, which is a really interesting open source software consultancy, where it's had me doing much more time, doing an individual contributor working on RISC-V LLVM primarily, but continuing a bit of a theme, also a very perhaps interesting or non-traditional organization, being a worker-owned cooperative with very flat hierarchy, equal salaries, and that kind of thing. And that brings us basically to current day.
Well, that's a very illustrious career so far. So, how do you see your learnings all across from Raspberry Pi to Low Risk and at Igalia? So, what are different kind of things you learned all along? That you can kind of count on saying these were different aspects of these career paths.
I guess a common theme for me, or the thing that's motivated me most, has been, open source and community. I suppose there's been a common theme a lot, and that's been one commonality. Another one has been like open source or doing good, but with a business model. Like that was Raspberry Pi's big innovation, which wasn't my idea. That was Eben's. That was we'll aim to improve computing education for children, but there's a business model there because we'll have this low-cost single board computer that'll be great for that use case, and loads of other people want it too, and of course that worked exceptionally well. I think with Low Risk, we kind of saw what had been achieved with Raspberry Pi in particular on the community side, where in those early days, it was people like me acting as a volunteer, building up a lot of the software stack, sharing tips, working on packages. That had been hugely powerful. We felt there were opportunities for doing more of that on the hardware side of open source silicon. But again, you need to have a revenue stream to keep things going, to have people working on it full time alongside, maybe academic contributors or people who are contributing in their spare time. And yeah, it definitely took us a few tries to find. It took a while of if you look way back at the initial announcement of low risk, we were quite a lot more focused on like Linux capable systems, like test chips that could run Linux. But it was only when we kind of got the partnership with Google working on OpenTitan, when there was that, I guess, a perfect alignment in terms of there being a very concrete business need. So OpenTitan, if you haven't seen it before, it's a open source root of trust. So it's all about like storing key material and particularly boot verification. So it's going to be used on either Chromebooks that are on the market today or in the near future. That's all public and announced. But it's a big competitive advantage, at least from Google's perspective and others, if the solution is open source and fully auditable. So that's a huge benefit over the existing ones, and that aligns with the business need. And so business need means it makes sense to sign checks and help get it done and put engineering time into it. And of course, these days at Igalia, it's maybe a bit more straightforward in that we're a consulting company, but we're a consulting company that tries to do good by working on exciting, interesting open source projects. Probably best known for work on browser engines, but Linux kernel, Mesa, and myself and close team members on LLVM and other compilers.
Mm-hmm. So what got you interested into RISC-V?
Yeah, so with RISC-V, that was low risk happened to start at just about the time that RISC-V was coming out of Berkeley. So this was back in 2014 or so, I think. So that summer, we decided that we wanted to, do something to try and make open source silicon a reality. So open source down to the RTL. So effectively, the level of writing, code for your processor logic. There'd been attempts to do this before in other projects. We're part of a larger community. I won't pretend we're the only one looking in this area. And because of that, we were looking at what other people had done in terms of choosing an instruction set architecture. Because ARM obviously isn't an open architecture. You can't just go and implement your own version of it unless you want to be sued by ARM. Same for x86. And so we did I did an exercise of looking at what was available, what people had done. The options there were, OpenRISC, which was a previous attempt at a open ISA, which built up a great community, helped us get kickstarted a lot. I made great friends there, and a lot of them moved on to RISC-V. But it was very much a 32-bit design. So you had the advantage of a bunch of work that had already been done, but maybe a little bit of a dead end. I think a version of Spark could be an open standard, and then some of the people around the corner from me at the computer lab working on Cherry, the initial versions of Cherry, which was this extensions to an ISA for spatial and temporal memory safety. They were working for their research with a 20-year-old version of MIPS on the basis that, of course, 20 years is a time in which patents expire, and so that was safe to use. And then there was RISC-V, which, just coming out of Berkeley, super new, no stable not really a stable compiler or anything like that, but seemed to be a bit of a buzz about it. We could get involved and help move it forwards. And looking at how things have gone, I think it was the right choice. Very much meeting a need as well. We had a need for an open ISA, and of course, we were focused on open source silicon, so open source designs. But the idea of RISC-V is to support open source implementations, but also proprietary ones, and whatever people want to do. It's an open standard, much like SQL or HTTP or HTML and like.
Yeah, that's really neat. So you've been involved with RISC-V pretty much from the start. So.
Yeah, near enough. Yeah.
Yeah.
So is that why you got into LLVM as well, specifically around RISC-V work? Or
so I'd started with LLVM working on this research architecture for when I was working towards a PhD. So that's when I dived into the deep end in terms of doing my own downstream back end. So this And I think I'd started LLVM Weekly at some point after that. I'd done for RISC-V. I hadn't intended to get stuck into the upstream RISC-V work in the way that I did. Like most people, I think there was the classic open source community failure mode where everyone sees there's this need. We need upstream RISC-V LLVM, and everyone assumes someone else will do it. People are starting startups. The Berkeley folks will do it at some point, or people doing R&D work. I assumed someone else would do it, but then it didn't really happen. And so I decided that, actually I was quite well placed to start the upstream RISC-V LLVM work, because doing the downstream kind of ports, I'd learned everything about what to do wrong and how to make it a bit of an unmaintainable mess, and all the hassle I got into. And so I had that opportunity to do it with a clean slate, build it up very incrementally. I did a few tutorials and things about how I'd done that, and it's very pleasing to see that. I think those are, even today, those are referenced, and people have pointed to that patch set as an example of how to kind of incrementally get a backend upstream in a way that's reviewable kind of from the first patch.
Sure.
So talk us more about, so it's about piecemealing your stuff, I guess. So make it digestible, right? Because backends are huge, and you can either throw the whole blob and then rub your hands, or how did you approach it? Like, what was your thought process in putting that together?
Yeah, so a lot of code reading and looking at the commit history of kind of the last few backends. I guess a combination of the most recent ones, as well as I read an awful lot of code in that time, trying to get a feel of for the common kind of implementation challenges, how different backends had handled them, to what degree a consensus had been found versus different backends using slightly different hacks. For the actual process of trying to get the minimal patch, there was a degree of looking at where people had some success doing that before. I think there was a code play tutorial some years before where they tried to build a kind of toy backend that gave some guidance on ways to split it up. But of course, the thing with LLVM, as you might know, is that it's a lot of its internal APIs change over time. So there's a lot of trial and error, and seeing how things have evolved. So I basically one decision I made was to start from the machine code layer up. So that's LLVM speak, basically, for the assembler and disassembler, which might seem kind of obvious, but the LLVM didn't get support for the integrated assembler until sometime into its history. I guess it'd been a few years by then, but I said before that I'd worked on a binutils port, and that was because that LLVM at the time, the integrated assembler, was relatively new. And so a bunch of backends had been started. They'd started doing code generation and then added the assembler afterwards. But it worked out quite nicely to build it up from the assembler, because it's easily testable. You can split it up nicely. And then you have that fiddly task of trying to bootstrap the back end, of getting a little bit of code gen, just enough to have a function that returns that doesn't add and returns the integer, and then start adding some more complex operations and control flow and the like. So for a while, I maintained a patch set that I tried to rebase to try and show this is how, if you removed the RISC-V backend today and redid it, this is how you do it. But I think around the time my son was born, I ran out of time to spare time to keep that updated.
Yeah.
So when you started, what I don't know if GCC was supporting RISC-V at the time, but what was kind of the decision process, or the momentum at the time between LLVM and GCC, or how was that?
Yeah, so GCC had fairly reasonable support. Both had. So there had been an initial attempt at RISC-V support in LLVM from some Berkeley students, but the challenge was it wasn't in a good state for upstreaming, because it had a lot of bugs and issues. But it's kind of that comment, like, if it had been a lot more minimal, it would be a lot more easy to upstream, because they implemented an awful lot of stuff, but there were all kinds of bugs and issues, and trying to figure out what was going wrong was very challenging. And they both actually took a fairly similar route, in that they started with MIPS and then changed a whole bunch of, and basically used that as a starting point, and then modified it until it looked more like RISC-V, because at least for MIP64, there's not a huge amount of difference, particularly if you're once you strip out the branch delay slots and things. It's turned out that worked really, really well for GCC. Didn't work so well for LLVM.
All right, so I think you've been kind of hands deep on LLVM and RISC-V specifically. And what are your thoughts on compiler future? Where is it headed to, in this modern computing world?
Yeah, I think that's an interesting question. There's clearly, I mean, in the time that I've been involved with LLVM, there was, a period with more and more people being, moved on to GPU in general, or sometimes graphics drivers. And of course, now it's all a very specific use case of GPUs or accelerators and frameworks around AI, either inference or training. So there's clearly an interesting path in terms of compilation for sometimes more novel architectures, or sometimes cases where you need a different type of compiler or faster iteration, where it's not so much general purpose compiler. There's very specific types of kernels that you want to compile and iterate on very, very rapidly. So I'm quite interested in work in that general direction. I know Tobias Grosser's group at Cambridge, they've been doing some work on taking MLIR, which is kind of has been a very exciting area of the LLVM ecosystem in recent years, where it's one of the challenges is that a lot of the kind of work that people are deploying using MLIR is all with downstream dialects. So taking a step back, I suppose I should. MLIR is unlike LLVM-IR itself, which is a fairly more straightforward kind of predefined set of types and operations and the like. MLIR is trying to be more of a container format so that you can build your own abstractions and integrate into a common set of passes and infrastructure for building passes to make it easier to build maybe a more domain-specific compiler versus LLVM-IR, which has been used for lots of things, but probably works best when it's a C-like programming model. And at that, and at some level of abstraction that's below C, but a little bit higher than assembly language.
So do you think for the heterogeneous compute, is that the way forward? Is MLIR the answer?
I mean, I feel I'd be speaking outside my area of expertise, in that I've ended up getting more and more into a kind of general purpose compute and RISC-V optimizations there for fairly standard inputs. I think I'm quite interested in that. I think the work I started to mention from Tobias Grosser's group is looking at kind of adding a code generation backend directly to MLIR. The idea being that you can, for cases where you're targeting an architecture that's a bit weird, a bit wacky, cases where you'd be fighting against LLVM's register allocator and optimizations all the way, why bother? Why not have a framework that might not have all the same set of standard optimizations, but a lot easier to work on and modify for, your streaming register file or whatever it is that's a little bit weird. So I think there's probably more room for different compiler technologies that still find a way to share a common base, which it seems to be where MLIR has been very successful. Even if lots of people are building their own pieces on top of it, which remains downstream, there's a common base that people share. For accelerators in general, it's hard to know. I've been following Chris Latner's new project. He's got this startup Modular, who have the Mojo programming language that's aiming to tackle this problem. I've enjoyed following what they've said so far about that. I'm keen to see how it pans out.
So what's new in RISC-V, specifically in latest, like LLVM 20 and 21 upcoming, I guess?
I think we've moved on, maybe over the past few years, moved on mainly from, as you can imagine, bringing a backend up to speed. Initially, it was just getting the functionality implemented, getting the very, very core functionality implemented, ironing out the bugs, doing more testing, making, doing the low-hanging fruit in terms of finding cases where it's generating totally silly code because we hadn't implemented some hook for an additional pass and the like. I think a lot of the effort over recent years has been on, there has been always been an ongoing strand of scalar code generation optimization. So every release, there'll be a little bit extra, a little bit shaved off, additional improvements, but more and more on the vector code generation story. So over the past, 4 releases or so, that's come on massively from, vectorization on RISC-V, the code gen, going back a couple, 2 or 3 years, code gen support kind of being there, but if you turn on auto vectorization, there's a good chance you get code that maybe slower than the scalar version, or it doesn't vectorize at all. So there's been lots of work to improve costing models, make changes to the shared infrastructure where there are cases where it makes choices that don't map very well to the RISC-V vector architecture. And I think I'm giving a talk about kind of an update on RISC-V vector code gen in general at the RISC-V Summit Europe, which, as we're recording this, is next week. I'm not sure when this will go out. And I think the main headline there is over the past couple of years, we've got about 9% geomean improvement on vector code execution speed. So this, which has been a result of quite a lot of work going through and finding cases where we're generating suboptimal code and trying to do better. I imagine there's still, more to do, more to go. Made good progress there. Another development would be, as more hardware gets either close to market or becomes actually available, more tuning for specific microarchitectures. So moving beyond just generic, make it so it's it should be better for most people to actually looking at a particular design and microarchitecture and trying to tune for the design choices that it makes.
Yeah, so I guess one of the things that RISC-V will have is the ability to have all this slight variance, and I guess that's important from that aspect. And do you think that the code gen is as compared to other mature architectures like ARM64 or x86-64, it seems it has made a lot of progress so far, but what are some of pending or wish list for RISC-V?
Yeah, I'd say that we've moved away from kind of big flashing lights, big ticket items, to a lot of, I guess, detailed performance analysis and tuning. So I think to a large degree that's what's missing in that. I think the RISC-V backend has been very successful in going from initially just me contributing to now, dozens of engineers across, a good handful of, well, probably dozens of companies overall, but maybe about 6 companies or so being the main contributors. So there's been a real success there in terms of having more and more people collaborate upstream, but it's still, there's still a far smaller number of engineering hours that have gone into it versus some of those more mature backends, and particularly the bit that's maybe not so obvious upstream, but people who are actually deploying this stuff. The install base for ARM, ARch64, and of course x86 is obviously many times larger, and so there's a lot more people going through, kicking the tires on particular code bases and seeing that maybe the code gen isn't quite optimal here, and companies who have teams who are looking into that. So I think there's a lot of filling in the gaps there, really, where there's just it's maybe hard to pinpoint a particular area, but there's lots of detailed finding benchmarks, pulling apart what's going on and where it's where we see it looks like we could be doing better.
So talk to us about your LLVM weekly newsletter, and I'm subscribed to it. I read it every week, and it gives a really good summary of what happened in different parts of LLVM work groups or areas, and it's really nice. So how long have you been doing it, and how many editions have you put out there, and how do you do it?
Sure. So for how long? It's about over 11 years now. So it started way back beginning of 2014. Somehow gone all of that time, every single week, never missed one. I think someone suggested to me after the 10-year mark, I should have missed one just so I would have done it. And then I could have, hit that and been happy. And I think that good advice, but poorly timed, because if I'd realized what good idea it was then, I could have, had my freedom and not feel I have this streak that I can never break. But yeah, it's been, 11 years. It's heading toward the 600th issue in the next couple of months. And
Wow.
I started it, back when I was working on that research architecture. It was partly because I was as I was learning more and more LLVM, one of the best ways I think of learning any open source code base is seeing the upstream development, seeing what kinds of changes people make, the comments people write for why they're making those changes as they make the commits. I was following quite a lot of commit history, and also just to see if, it's quite common people will introduce a new interface or make a cleanup and you think, oh, I could use that for my backend, and I could go and start using it. And so it started from finding I was doing quite a lot of that and thinking, yeah, I suppose I could write this up and other people might find it helpful and it wouldn't be a huge amount of additional effort. And yeah, it came from that really. It's kind of interesting the journey, to me, I'd had with LLVM, because at that time I was very much a downstream LLVM developer. I think I'd maybe been to one LLVM developer event. I felt very much an outsider to the whole community, but figured, I'll give it a go. I was very excited to get so much positive feedback, particularly from big names, Chris Latner and the like, who seemed very keen to see it. And yeah, over time, particularly with the RISC-V LLVM stuff coming, once that started, it had more ability to work upstream. And probably like many of us particularly getting started in your career and getting involved in these big projects, you start with a bit of imposter syndrome and you start thinking, I know nothing. There are all these people who know everything. And over time, I guess you learn a little bit more, realize that often it's the case that people know a lot in particular areas, but maybe not so much in others. And of course, there is that small percentage of people who genuinely do seem to know, literally everything about everything, but they're always fun to talk to. They're just hard to fathom.
Yeah. Yeah. And I guess like it's also a learning experience for yourself. What you learned, probably you summarize, and it kind of like sits better with you from there on. So it helped you in that way, or?
I think that's probably why it's kept going for this long, really. I think, there's, I probably don't love every minute that I spend writing it, but overall I learn a lot each week. And I think that the skimming through commits bit is a bit I always enjoy the most, because it's, I always find something interesting or fun I didn't realize people working in this area. So yeah, I've always gain a lot from doing that. And I hope that other people gain something from looking through my summaries in a similar way.
Yeah, I think especially people who are on the new or trying to learn, and they're trying to kind of become part of the community, this becomes quite important for them to kind of get to know it, and then swim through the information as they learn more. So it's very useful. LLVM community, they ran their own like fabricator-based review system, and then there was a big migration to GitHub. So what are your thoughts on that? Has it been like beneficial or challenging? And
Yes, it's a fun topic. I think it's interesting with LLVM because that transition has been interesting for a number of reasons. So LLVM, it struggled over time with its decision-making process, in that, going back to when that transition started, you have, Chris as the, kind of technically benevolent dictator for life, but he doesn't really use that power much. He kind of steps back, which I think is probably overall very healthy, but it does leave a bit of a gap in terms of what the process should be. They later added in like a contentious decision-making process, but that's very rarely been used. Much more recently, in the last year, there's now this idea of area teams and a decision-making process that they can get involved in and help drive forwards. So, I mean, with the GitHub migration, it took an awful long time to get consensus and get people moving. I think there was, a lot of people put a huge amount of time and effort into that, for which I'm clearly very grateful. Many of us, I suppose, working in tech in particular, for some reason, we're a bit resistant to change. So moving to GitHub, fantastic in terms of attracting new contributors, having a familiar workflow. For me personally, there were things that I liked, I still miss from Fabricator, for sure. Like Fabricator had a nice tool called Herald for subscribing to for commits that match certain criteria, or reviews that match certain criteria, which we've kind of emulated some aspects of that with bots, with GitHub Actions, but it's a bit clunky versus what we had before. And fundamentally, the kind of Fabricator review model matches my way of thinking a little bit better. So being able to submit a patch, and then you have N versions of that patch, and you can go and compare the inter-patch history. That doesn't work quite so well in GitHub when you're kind of forced to either do a rebase and force push, and then GitHub doesn't keep track of the previous versions, or you keep adding additional kind of incremental changes, which again is a bit of a divergence. It's a change. I think overall it's been a good change. I certainly wish that I know that people who are more used to Fabricator or Gerrit workflow often have this feedback. I really hope one day GitHub will think about if they could do something that makes more of us who are like that workflow a bit happier.
And I think the overall number of commits that are kind of landing, has that frequency gone up, or what's your idea about that?
I imagine so. I haven't drawn a graph, but certainly, the time I spent going through commits certainly doesn't seem to get shorter each week. And with other projects joining, I think LLVM is continuing to be a more and more active project. I'm curious. So I wonder if someone has run the numbers and if we've had more kind of newcomer contributors. But I'd be surprised if we hadn't. I put it like that.
Yeah. So the other question around there is that LLVM, it used to be separate projects, and then it kind of chose this mono repo approach, where a bunch of those sub projects combined together, and then earlier you were just building them together, but then it became a single repository eventually. So what's your thoughts on going granular versus mono repo?
I mean, as a contributor and developer, I absolutely love it. I think it may make pain for people who are downstream packages and the like. I know that there have been complaints about the difficulty of building compiler RT or some of the runtimes and the way that was integrated. But I think as a developer of LLVM, and also probably because of the way that LLVM is written and developed, because we do have these common core LLVM data structure libraries in LLVM ADT and other interfaces that are used across multiple projects. If we'd had that split across multiple repositories again, then it's rather painful to keep that in sync and try and split commits across different projects when you have a common dependency. So I think that I'm not someone who's had lots of experience working on, there's well-documented cases of, Google and companies like that having huge mono repos. Never encountered that, worked with that myself. LLVM is the main mono repo project I've worked on. So it could just be me being blinkered, but I really enjoy it. It works well for me.
Yeah, I think there are certain other projects, which kind of take a similar approach as well, where I think it becomes easier. Of course, there are downsides of probably, you building a lot more than you need, but I think it gives you that complete view, more consistency, I guess, and that helps. So on LLVM, where do you kind of see it in terms of cross compilation? Because I know in a long time before, cross compiler tool chains were a magic to build from GCC. You had quite a process where there were catch 22s and things like that. So you would basically do this phase one, step 2, and likewise. So it wasn't an easy way to bootstrap a tool chain. How does it contrast in LLVM Clang world?
Yeah, so one of the great things about Clang is that every build of Clang, as long as you've enabled multiple backends, is a cross compiler. That aspect works very well, very nicely. I think where there's a bit of complexity or a gap is moving from the kind of thing I do, which is build it so it's enough as a cross compiler, I can compile and run some test code with a particular set of libraries, to making it a tool chain that I can distribute and share with users, customers, whatever it is. And particularly when you start worrying about multi-lib supports to handle, like when you build GCC in one of those often convoluted or complicated processes. At the end of it, you may get out a GCC where you can, based on whatever -march or ABI flags, it will pick the correct versions of libgcc and other dependencies. Clang does support that. Some aspects of that, there are some gaps, there's some complicated. In general, it's a complicated and fiddly bit of the compiler, maybe not the most beautifully implemented part of it, like the what's called the Clang driver code, which is effectively everything that handles once you take your C input, how you go and pass that through to linker and external programs. There's quite a lot of copy and paste and slight mess there between different targets. So as somebody who's has to try and interpret or debug reports from users, that's often not a particularly easy or enjoyable experience. So yeah, I think Clang definitely has a lot to offer there as a cross compiler. Companies like, I think Arm's now open sourced most of their stuff around how they build their kind of Clang-based toolchain that they distribute. So there's a lot of groups who are using it in that kind of way. I suspect that there's, I think the bit I normally have to chat to people about is that gap between, yes, you can take a build of Clang and put in, whatever -- target or -march you want, but it's those access to libraries and building a sysroot and that kind of thing is where you still have to go and put in a bit of work or rely on someone else having done that work for you.
So I think moving towards your writing again, because me and Cliff, we do talk a lot about writing. We're trying to write more, and so we learn from others. And you have your weekly newsletter, awesome, and then you also co-authored books. And so could you kind of talk about some of your process and your co-authored books, and if you're writing any new ones in that area?
Yeah, so I think it's one book I managed to write. This was co-authored with Ben Everard, Learning Python, Raspberry Pi. It was a long time ago now, so it's all in a little bit fuzzy. I suppose we put a lot of work coming up with a top level outline, and then fleshed it out beyond that, parceling up the work between us, and I think for that kind of book as well, in particular, given it was a book about bringing people along a journey of this is how you learn to program. I think most of a huge portion of the effort was in figuring out what order to introduce things in, what kind of projects you get people to do, and that kind of thing. Once you had that structure, then it was a bunch of effort, but perhaps a little bit more mechanical to actually go and flesh it out. I've certainly not worked on anything book length since then. Since I joined Igalia, one of the things I did was find time to set up a personal blog and start to put a few technical pieces out there on muxup.com, where I think I'm always, probably almost everybody, I imagine it's a common theme when you're discussing writing here. Everybody wants to find time to write more or find a way to get more out there. So I'm always trying to do a little bit more. I've experimented with different things in terms of blog posts. Like I've tried to I've taken recently to, I have I've always written down an awful lot as I work, a kind of, work log, just almost like a local cache of, this is what I tried, this is what happened, I'm thinking about trying these things. And then if I get called away or distracted, then I can come back to that. But then I often find that it's helpful to put a little bit more thought into it, writing it up in a bit more structured form, which is a bit like a mini blog post. So I kind of keep track of I basically have a local version of the site generator script that I use for my public blog for some local notes, where the hope is that over time some of the things are work out nicely and I graduate them to going public. In practice, there's quite a lot of things that have been half finished and the like, but it's probably still a better, probably still a useful source of ideas and reference and things that I can pull on for more public writing.
Mm-hmm.
Yeah, it's very interesting. You talk about doing a lot of logging as you work, and that is a very powerful technique when you're dealing with complex systems and complex problems. So that's
I don't know how people manage to do it without it, to be honest. I always find I've always been it's one of the things I enjoyed with the large language models, with the recent introduction of the chain of thought ones, like the particularly the DeepSeek chain of thought. It's kind of, oh, I'm thinking about this. Oh, I'll consider the other options. It's quite endearing. It kind of matches my own thought patterns, and often I'll sometimes I'm really stuck on something. I'll just literally do that chain of, just write down whatever's coming into my head and then look back at it and see if anything made sense. So I kind of relate to it somehow.
Sure. Yeah. So on your blog, I see like 2025 Q2, Q1. Do you try to do like one post a quarter? Is that your target, or
no? Ideally, it would be more. I've just been a bit slow recently. I think I've just tried to. That's the quarter splitting thing. It's mainly came from a trying to find a balance in terms of indicating when things were written, but without being too overly precise. Because if you only post every few months, does it really matter whether it was February 1st or March 2nd?
I see. Yeah, that makes sense.
So, what are some of the technologies that interests you for future?
Sure. I'm quite interested in kind of programming language development in general. Not as I can't pretend to have made any contributions there. I'm mostly a follower, but I've in the very early days of Rust, I quite closely followed a bunch of design discussions. It was a fun distraction, perhaps, from things I should have been doing. So I'm quite interested in the continuing development of memory safe languages in general. So yes, Rust, which is obviously already a huge success story and continually developing, but also other languages that try and learn from Rust and make slightly different design trade-offs. I think there's an interesting design space there. Carbon is one of them, looking at for greater C++ compatibility, that hasn't so far had a very good memory safety story, but is now more of a focus. And I mentioned Joe before as another interesting one where maybe learning from some aspects of Swift, which was very successful in having a kind of easy to read baseline language, but over time has become, at least to me as somebody who's mostly following it from the outside, it's grown an awful lot of features and complexity. And it'll be quite interesting to see if Mojo manages to manage that, or whether once you start adding in all the compile-time programming features and type system and handling of memory safety, it becomes similarly complex to any other language in that class. So that's one thing I'm quite interested in following. I mentioned LLMs before. I'm particularly interested in what people are able to do with large language models that have open weights and that you can run on your own or rented hardware. It's really exciting for me that there are options there that are relatively competitive, and you're not tied to using any particular vendor. And although there are plenty of pros and cons of those tools and things they work well for and things that they don't, for other tools that sometimes scratch the same itch, so information retrieval via Google, we've never really had that ability to just have your own local version of it that works similarly well. You can have a local version of a much smaller search set, but the people haven't been very successful. Whereas with DeepSeek and Mistral and other people working on models that are MIT or Apache licensed, I find that quite exciting and interesting. And particularly for I think Simon Wilson described it as side projects, as side quests. So these side projects, it's not like your main thing. You're doing something for fun, for experimentation. It can be nice to have something else in the mix that can help to add input to what you're doing. There's probably another element, which is over time search results have got worse, and so you're kind of stuck you're pushed more towards using those kind of tools. Beyond that, I did some work with WebAssembly when I first joined Igalia. I remain really interested in how WebAssembly evolves, particularly now that it's becoming much more capable on the browser side in terms of adding kind of more features for interoperation with JavaScript, but also at the same time seeing quite a lot more adoption on the server side for things like function as a service and fast startup, or for providing a different kind of abstraction for people who want to have memory safety, but within like a container that might be within a software fault isolation within a single process, for instance. And finally, probably I've spent an awful lot of time with LLVM and the LLVM code base. I enjoy that. It's great fun. I don't have any, nothing's kind of making me want to put it aside, but new things are always interesting. And so I'm really interested in projects like CraneLift that are trying to build learn from other compilers and build something, build a new compiler, in that case in Rust, and trying to do something slightly different in terms of how instruction transforms and combines, as it's called in compiler terminology, are implemented and specified.
Yeah, I mean, there's an interesting talk by Matt Godbolt, from godbolt.org fame, which is called Correct by Construction. I think APIs that are easy to use and hard to misuse. So that talks about the memory safety and how Rust does things and how you can misuse the APIs, if they were written in, say, C++ or something. So yeah, it's pretty interesting, that talk, and I think I found that quite amusing to learn that there are different ways that you don't think about, that how language can provide you like safe way to do things. So,
I'll have to check it out.
Yeah. I think he has a lot of good stuff out there. I listened to his podcast. It's called Two's Compliment, and it's a really cool podcast. They talk about some tech stuff there.
Nice.
So what tools do you recommend? Because a lot of people, they wonder about we are always looking to improve our toolbox, getting better at things we do, and we are kind of like exploring, our editors, our terminals, our distros, what have you. So what does your setups look like?
It's fairly static. I mean, I put myself in that category as someone who's always trying to look to improve their toolbox, but what I mostly end up with is familiarity. So for me, I think I couldn't use a computer these days without a tiling window manager. I use DWM. I've used it for, 12, 15 years or something now. It's basically always looked exactly the same color design. I don't upgrade my distro and all of a sudden there's a slightly different style. It's just, this is how a computer user interface looks to me. And it for me, who always has a few terminals open and wanting to whip around between different workspaces and move with and the like, I find that works really well. Otherwise, I'm a Vim user. I'm someone who keeps thinking I should move across to NeoVim, particularly as I really like Lua as a language, and having that as an extension language makes a lot of sense. But I think, like many techies, get a bit caught up on wanting to do things themselves. So my blocker on moving to NeoVim is that, well, I want to do that, but as part of it, I want to write Lua versions of all the plugins I want myself, and so I'll never finish that. But that's something to keep me distracted every now and again. And otherwise, I end up having a pile of scripts and helpers, slightly esoteric setup about local document track, personal wiki type thing, and tracking time that I spend on different projects and the like. So I'm not sure I have any particularly amazing reusable tips. I suppose a thing I found helpful over time is to you can overdo it for sure, but I think most of the time when I've put aside a bit of effort to figure out if there's something that I'm frequently doing manually on my system to try and package it up in a little script that I can reuse and help me, it's been worthwhile.
Yeah, that's a very something we probably should do more of is just look for things we do repetitively and write a tool for that. So yeah, I appreciate that.
Yeah, familiarity is actually pretty important from productivity point of view. I think, so there is one end of it is where you're distro hopping, right? So you're kind of like switching. Oh, I'm going to use Ubuntu, and then next day you're on something else. I'm going to use GNOME. I'm going to use, Plasma, whatever, or other things, right? But that's like other extreme of it. And but I guess from productivity point of view, having those core set of tools, carry on with you, it's probably very useful and very beneficial.
Yeah, absolutely. And I think for distro wise, I've used Arch Linux for a fair amount of time, and it's well known for its wiki being a great source of information. And for the kind of stuff I do, it's very helpful to not have that. Well, to have packages that are constantly up to date, they match fairly closely upstream, not have to worry about enabling a particular personal package archive or whatever you do on Ubuntu these days. I found that quite helpful, as well as for somebody who likes to exert quite a lot of control over their system, it is helpful to have a system that's designed with that in mind.
Yes, definitely.
Yeah. So any specific reading recommendations, blog posts, YouTube videos, that you like to mention about?
Yeah, I don't know. I think I haven't really read many new programming books for a fair while. I think Thinking Forth by Leo Brody is always one that I have in mind as being it's available for free online. You can download it. It's a nice, easy read. It's kind of targeted at relatively new programmers, but I just find it's a really fun, interesting breakdown of the kind of problem decomposition process. And what I find is really interesting about it is that although I have no real desire to ever write Forth, I've never written Forth, you can read it and step through it, and it almost makes you think, I could become a Forth programmer. Maybe I want to be a Forth programmer, because this seems like, but it's not really about Forth. It is more about, just this is how to take a problem and break it into steps. But yeah, I just always found that I find it, particularly as someone who's been, over time interested, like with going back to Raspberry Pi, interested in that process of how you get people involved in computing and programming in particular. I found it quite inspiring at how he seems to have done it in such a engaging way, particularly with a language that's is maybe a little bit obscure or unfriendly to most.
It sounds like a timeless book.
But yes, for otherwise on yes, I don't think I have particular blog posts to recommend. I enjoy keeping up to date with the Lobsters is quite a handy aggregator of people submitting different things, and in general, I mentioned I'm interested in following language development, so the Swift Evolution Forum and Rust internals tend to keep track to see what people are proposing in terms of RFCs or language feature development, in the hope of mostly skimming through and learning some things via osmosis. It's fun to dabble a little bit outside of your usual work area.
Cool. So any advice you have for newcomers who are learning and trying to get into the tech fields, software compilers?
It's a tough one, and the field is changing and evolving over time. We mentioned AI a few times. It'd be interesting how things pan out there for new programmers. I think for me, finding a way to get involved in open source is what really opened a lot of doors for me. So going back, actually, my first involvement, it was Google Summer of Code, actually, in way back 2006. I think that was the second or third year that they did it. So that was my first experience of, I was somebody who'd written a little bit of code at home, but it was a great opportunity to get involved doing an open source project. It was actually with the Ruby programming language way back then. And so that kind of gave me the taste of it, in that for a long time I thought that seems fun, learning about something I could do, but then I actually had that experience of I did it and it was fun and I can do it, and I was in a position to try and find more ways to get involved in open source and follow them and follow open source projects. So Yeah, and particularly for in terms of career opportunities, learning new things, it's hard to compare because I've never really gone down that proprietary track, but I've always felt that I've had many more doors open to me because I've had that experience of doing things out in the open, and also it's there in public. If anybody wants to know what I can do, what I have done, they can look at the things that I've submitted online. And being on the other side of the table, as I have been at Low Risk and at Agalia, as we try and hire new people, I know it just certainly makes life a lot easier as an interviewer if you can go and look at what people have done.
Yeah. So it's sort of your open resume, open kind of like a static resume that carries with you irrespective of where you work.
Yeah, exactly.
Yeah, that's great advice. Well, we appreciate you coming on, Alex, and I appreciate all our listeners. If you have any feedback, please reach out to us. And until next time, thank you.
Thank you very much. Thanks for having me.
Thank you.